All right, we're going to discuss Pythagorean inequalities in this short lesson. And before I do so, I want to go over a couple of quick concepts. I won't spend too much time on it. We've done this before. This is just a refresher for you. Given a triangle, the sum of any two sides must be greater than a third. And if we were to look at this real quick, and we have a triangle here, all it's saying is that we just have three sides. Call it M, N, and P. And the reason I chose those letters is because I didn't want to confuse it with the ABC of the Pythagorean. And what we have here is just any three sides, so m plus n have to be greater than this third side, because we can get scenarios to where we can get an m and a very short n will not make it to connect to this side over here. And something like this would be like if this was 12 and this was 3 and this was 5. All right, we're just a little bit too short connecting to this 12. So this leads us into our next idea. Once we get into forming triangles, we can make them right, obtuse, or acute based upon the relationship of the longest side, theoretically the longest side. And we have something that you've seen before. We have the right triangle from the Pythagorean. C squared is equal to a squared plus b squared. And we're putting the c first because that's where the emphasis is on. Obtuse, the c squared is going to be bigger. Because look what happens. Here's our right triangle, all nice and happy. Then the C grows. Well, it pushes that A outward like a door hinge. Just pushes it outward, making this angle obtuse. And when that C squared gets smaller, well, that A just has to collapse inward and make an acute angle. So we're going to use these three concepts in our next examples, as well as making sure that we can form a triangle. Our first one. Given sides 4 and 7, what is the possible length for a third side? Well, we don't know what the third side is, and in algebra we would call that x. So here's our three sides, 4, 7, and x. Given the fact that any two sides have to be greater than a third, we're just going to have to play around with some inequalities here. I'm going to take these two sides here, 4 plus 7, and it has to be greater than x. So 11 has to be greater than x, and for our left to right people, x is less than 11. All right? So that was scenario 1. Well, I could pick any number less than 11 and I think I can form a triangle, but that includes negative 45, and of course that doesn't make any sense. So we're going to have to put some restriction on this. We're going to have to look at other possibilities. So I'm going to take the 4 and the x. So I do x plus 4 has to be greater than 7, and that gives me x has to be greater than 3. That was my second scenario. I could do the third, but I really don't need to, and after a couple of times you're going to realize why. Because what we have is x plus 7 has to be greater than 4. Right now we're going duh, of course. That makes x has to be greater than negative 3. That's an extraneous solution. To write a compound inequality out of these two guys, all we do is x is greater than 3. So there's my 3, there's my x, and there's my 11. All I do is pick any number between 3 and 11. Someone may pick 4, someone may pick 5, someone may pick 10.9. There's all kinds of different solutions that y'all can have. Let's take a little bit more complex problem, because we're going to combine the Pythagorean inequality on this. Given an obtuse triangle with two sides 7 and 9, what are the possible lengths for the third side? Let's go ahead and first find all the possible lengths. You're going to find shortcuts where you don't have to. You can kind of guess and check a little bit and think logically, because you can do 7 squared plus 9 squared has to be less than, because we're dealing with obtuse, the c squared, and you just come up with something like that and find a number that you can take the square root of that's bigger than that. But let's go ahead and find all possible values first. So again, I have three sides, 7, 9, and x. And I'm going to do 7 plus 9 has to be greater than x. So x is less than 16. And I'm going to do the x plus 7 has to be greater than 9. And we got x has to be greater than 2. So my compound inequality looks like this, 2x 16. I can form a triangle given any number between 2 and 16. To find an obtuse one, there's several obtuse and there's some acute ones in there. There's probably even a right one in there somewhere. We just got to find out where it is. And that right one can only be one single number. This is actually not that hard to find. You just solve using algebra. So let's take a number. I'm going to surprise you. First of all, we don't know which one is our C. Our C has to be the biggest number. So if I were to pick a number smaller than 9 right here, our C would be 9 right here. So let's go ahead and do that. Now remember, it's going to be C squared has to be greater than a squared plus b squared. Nothing says that any one of these is my A, B, and C, because the x can change. X could be 10. That would make it a C. It could be 3. That'll make that 9C. Let's go ahead and make the 9 squared our biggest one, because we're going to pick 3. And we're going to have 7 squared plus 3 squared. So we have 81 is greater than 49 plus 9. Well, that's obviously true. So we have an obtuse angle here. Okay? And I could have said, okay, well, let's just do something different. And let's call this x, say, 14. Now make it 15. Let's really go obtuse. So we have 7 squared plus 9 squared. And c squared, which is 15 squared, has to be bigger than that. So we get 225 is greater than 49 plus 81. Well, guess what? 15 also makes it obtuse, all right? And if I said find some that are acute, you would just do the process but make c squared smaller. Let's move on to the next example. And you probably want to erase this and redo this problem. That is like a good idea. Given a right triangle with two sides 6 and 10, what are all the possible values? This is the same math that we just did, but I have now broken down into 3 types of questions. So again, we have our 3 sides, 6, 10, and x. So we're just going to do 6 plus 10 has to be greater than x. Hopefully you're picking up speed on this, and watch this. X has to be less than 16. And then I'm going to do x plus 6 has to be greater than 10. X has to be greater than 4. So my compound inequality looks like this. And what are all possible values? Any number between 4 and 6. When I say any possible values, look at this right here. I'm not asking you to say 5 or 7. It has to be all possible values. That includes 4.01 and 15.9923. So express it as a compound inequality. Read the question carefully. Previously, I just asked you for what is a possible length. So you only had to come up with one. Here you have to come up with them all. What is the value of the third side that would make it obtuse? So again, we're going to be looking for something that will make it obtuse. That means the third side, the c side, has to be bigger than the other 2 squared. Let's use 15 again, because 15 falls in here, so we can use that. So again, c squared has to be greater than a squared plus b squared. Okay, so we're going to do 15 squared. I know that it's going to work out because I could just look at it. It is going to be greater than 6 squared plus 10 squared. So you got 225 is bigger than 36 plus 100. So all you have to do is right here is just say, okay, 15 works. Acute. We want c squared to be less than a squared plus b squared. So I'm going to look at this again. So I'm probably going to make 10 my c squared. And I'm probably going to make my x 9. So let's make 10 squared, okay? Has to be less than 6 squared plus, actually, we're going to make that 9. I said 9 squared, right? And that's going to be 100 is obviously less than 36 plus 81. All right, so we have an acute. So 9 would work. All right. So relook at these problems, and I would strongly suggest practicing these on a blank sheet of paper and then checking the work off of this. Because again, watching and doing are 2 different completely brain activities. See you next time.